I'm your host, Grayson Brulte. Welcome to another episode of SAE Tomorrow Today, a show about emerging technology and trends in mobility with the leaders and innovators to make it all happen. On today's episode, we're absolutely honored to be joined by Ron Poole, Global Director of Engineering and Product Portfolio, ENNOVI. On today's episode, he'll discuss ENNOVI's adaptive battery and charging architectures for plug-in hybrids and full battery electric vehicles. We hope you enjoy this episode. Ron, welcome to the podcast.
Grayson, thanks for having me. Excited to get into some Q&A session with you today.
It's great to have you here. The world of electrification and automotive is changing. It's whipsawing. It's going hybrids. It's going all electric. It's going here. It's going there. How is ENNOVI keeping up with the market, and how is that impacting how you're thinking about electrification today?
Oh, I think that's a great opening question from you, Grayson. I think when you look at ENNOVI and what we're trying to do with electrification, it's really about how can we help our OEMs deliver their new vehicle lineups faster and more efficiently. Certainly, we see a lot of changes going on within the EV market with switching from full electric vehicles to hybrids versus what we can do with those. So when we look at this from a perspective from the ENNOVI standpoint, we're really focused on two things. The first one is battery management, and how can we help our OEMs deliver the proper battery management with our CCS profiles delivering for them. And then the second thing we look at is really the electrical architecture for these different vehicles. How do we set up and design our different busbar technologies, and what can we do to help them make that the most efficient in the vehicle? Like you said, huge changes going on in electrification as we straddle that line between full EV and hybrids. So ENNOVI is really trying to make sure that we offer the right product mix so we can shift as the vehicle industry shifts, as we're seeing quite a bit of here over the last 12 months.
When you're designing those products, do you account for battery health and what the average life of that battery should be?
We haven't seen a big push for that in what we're doing on the ENNOVI side, just because we don't necessarily get into what we're doing with what the OEMs are getting into with the different chemistries that they see in those batteries. Certainly the chemistries are probably going to be the biggest area where you see the impact of what's going on with the battery life, and we don't really get into that. We're more centered around what we're doing with the cell contacting solutions. So we're looking at how the different portions of the battery, how they're interacting together, how we're making all the cells work together as one. So that's really been our focus in what we're doing with ENNOVI.
When you look at things that work together, how do you increase the range of batteries? Because there's a lot of anxiety in the market around individuals. Well, my electric vehicle won't go as far as my gas car. How are you working with the battery suppliers and the OEMs to increase range?
Yeah, that's a good question as well. I think when we look at what the OEMs and the battery suppliers are doing, you're seeing that customer want for a higher range in the batteries. So there's a couple of different ways that we see that strategy being attacked. Probably the most conventional way that we see that being done is by adding more cells into the batteries. So when you look at adding more cells into the batteries, it's really about how can ENNOVI then help to offer a solution that makes that more efficient in design. And when we talk about efficient in design, as your battery is getting bigger, of course, your cost is getting bigger and your weight is getting larger as well. So we're really set up with our designs for really looking at how can we bring in a solution that helps to reduce that overall size of the battery with what we're doing in the X, Y, and Z planes, but also with how are we making it less weight on the battery itself. So that's really where we strive on our designs, is how are we really getting efficient in the package to make sure that we're not large, and also how we're controlling the weight of those batteries as well.
How much impact does the weight of a battery have on range? Does that have a pretty large impact on the range?
Certainly it does. If you think about weight in terms of what we do with ICE engines, you're used to talking about miles per gallon. So the heavier a vehicle is, you're not going to get nearly as miles per gallon. So here, the weight of a vehicle is you're getting miles per charge. So we're always looking at, it's that balance between putting more weight into a vehicle to get you longer range with a bigger battery pack, but at the same time, really starting to keep the weight of the overall vehicle down. So you have to have that balance, certainly, with what you're doing there.
And speaking with your OEM customers, is there any data that you've found a pattern in where a consumer, this is the ideal range that a consumer is willing to pay extra for? Is there any data that you found along those lines?
I think you really get into, to be honest, regional specifics for what we're seeing there. And it's starting to talk about the convenience for what you want to do with that particular vehicle. I think when we look at the China market, the want over there is how do we get to the lowest cost vehicle? So the lowest cost vehicle isn't necessarily going to give you the longest range. So you see a lower range battery with what we're seeing on some of the China regional areas. When you compare that to with what we see in Europe and North America seem like they're willing to pay a little bit more for that longer range vehicle. So you see the desire for that longer range vehicle really starting to propagate in the Europe and North America range, more so than what you would see in the Asia Pacific range.
When you look at staying in Asia Pacific, do you think that's because the culture is open to battery swapping? Is that one of the reasons that you think you're seeing that, or is it just purely cost?
That's a good question. Battery swapping, I haven't gotten too much into that or know the ins and outs of that, but certainly with what we see for the overall cost there, I think that's probably where, again, we see that convenience factor coming in. With what we see in the Asia Pacific vehicles, the China vehicles, you see a very low cost vehicle. So with that low cost vehicle, again, you're going to get the lower range associated with that. So I think you're still going to see a desire to push those ranges up. We're seeing that come through with some of the OEMs that we have over in the Asia Pacific range. So I think there's still going to be that desire, but you're really going to have to, again, balance that equation of how much range can you bring into a vehicle by keeping it at that price point that you need to in that market as well.
Because you have to be price sensitive today. If we look at the New York Fed data, the more 90 plus days that consumers are delinquent on their auto loans, higher than COVID in 2008. The IMF came out today and said the U.S. is on a brink of recession, and EU is having their own issues as well. With that economic backdrop, I mean, do you think consumers would be willing, and I ask this from the EU perspective and from a North America perspective, be willing to pay more for an electric vehicle that has longer range, or do you think that it's going to have to be in that price point that's currently in the market today?
I think that's a good question. I think it's an unanswered question. I think with what we see, certainly in the U.S., we see the desire for a longer range. And I think, again, you're getting into that convenience. I think there's two things that we really probably need to look for here in the EV market before we see the sales really start to take off. One is range anxiety, and the other one is charging time. So certainly with range anxiety, the way you solve that is by putting more cells or a bigger battery into the vehicle. So are the consumers willing to pay for that? I think the answer is probably yes, but I think we have to wait and see after we put some of these newer vehicles onto the market with the longer range, how do we see sales of those? Do they take off? Do they stay consistent? Or do we see a consumer not willing to pay for those? But if you ask me my opinion, I think we're going to see in North America that with the range anxiety, we'll probably see a consumer that's willing to pay a little bit more for a higher range vehicle.
I agree with that, because even if the individuals who live in America don't use the range, they like the ability to know they have it. Because if you're going to fill up a vehicle 300, 400 miles of gas, maybe you'll have for a week, 2 weeks, depending on how much you drive. And staying on the front, you have old individuals, mostly older individuals, who have this obsession with the gas station. Well, there's one on every corner. I never have to worry. They're never going to get over the anxiety. They're never going to get over the charging time. To me, they're in an older market. They're for all practical purposes, they're set in their ways. However, there is an opportunity for those individuals to embrace hybrids. And in the hybrid market, as we've seen from all the sales data, is growing consistently quarter over quarter. How is ENNOVI supporting your OEM customers with this growth of hybrids?
No, I think that's a great observation on your part. I mean, if you look at hybrids are really that intermediate step between what you have for a traditional ICE vehicle versus going to a full electric vehicle as well. So it's, again, you're bringing in that philosophy of how can we bridge the gap to get from one extreme to the other. I also think it's interesting that you kind of see a transition happening in the hybrid market as well. If you looked at a hybrid 5-10 years ago, what we used to call a hybrid it was really using an ICE motor to really charge that battery as you're going. Where we're seeing the market really start to transition here over the last year or so is into the PHEVs or the plug-in hybrids. The plug-in hybrids is what I love about those is it's really just a scaled down version of electric vehicle. So you get the convenience of being able to charge your vehicle overnight and maybe get 100 miles worth of range out of that. But if you have that range anxiety, once you get to the bottom of that charge, then it'll allow you to switch over into the traditional ICE motor. So it's really starting to position the economy and the public into thinking, how do I really make that transition from ICE to a true full electric vehicle? So the PHEVs do a nice job of that. What we love about the PHEVs in ENNOVI is they're really just a scaled down version of electric vehicle. So you still have the same battery packs on those. You still have the same charging system. You still have the electrical system required to have a full electric vehicle, just in a scaled down version. So that fits our product catalog very nicely, because what it allows us to do is we can build an architecture for a full-blown electric vehicle where it runs just on electricity, but we can also scale that down for these PHEVs, and it really puts us in a nice position to be able to deliver architectures for both.
If you look at it from an architecture perspective, it's brilliant. If you look at staying in the hybrid market, do you see PHEVs growing and eventually replacing always the quote unquote traditional hybrids, where PHEVs become the fastest growing, most commonly available hybrids?
Yeah, absolutely. We've seen that transition already starting to happen here in 2025. If you look at the market data that we have in 2025 right now, it says that PHEVs probably make up about 8 to 10% of what we see in total vehicle market. We're working with some of our partners, IHS and some of the others, to look at, hey, how does that start transition here from 2025 to 2030? The predictions that we see right now in 2030 is we're probably going to see a market that's about a third. So you'll see 33% ICE, you'll see 33% hybrids, and you'll see 33% full EVs. But the majority of what we see in that bucket for the hybrids is the plug-in hybrids, or the PHEVs. So with what you have now, with probably about a 50-50 split of what we have with what I would call a mild hybrid versus a PHEV, by the time we get to 2030, we think we'll see the majority of those hybrids push over into the PHEVs.
What grows that? Is it the carpool lane that grows it when the individual, oh, I have a hybrid. Oh, guess what? I didn't have to go to the gas station for 3 weeks. Does that start to bubble up and start to drive this conversion? Eventually, you know what? I'm ready to go for it. I'm going to get rid of the gas. I'm going to go for it. Does that start to to build it up and help it get there?
I think it's the convenience. So, I talked a little earlier about that there's really two big things that are probably keeping us back from the convenience factor, and that's the range and it's the charging time. So the range, I think, is going to solve itself as we see these different battery sizes start to come in and out. I think you'll be able to pick the optimal vehicle for what you want to get with your range. But to me, I think the bigger factor is that convenience of charging time. So, the Tesla markets really dominated what we saw with the charging of vehicles for the last 4 or 5 years. And the superchargers could get you a full charge on probably about 25 or 30 minutes. So you could, as a family, you could plan around that if you needed to. If you were on a long road trip, you could say, hey, let's stop for lunch. Let's plug it in. It's going to take us 25 minutes. But it still really wasn't as convenient as just rolling up into a gas station, sticking the pump in, and having it fill up in 5 minutes. With what we see with some of the new introductions coming in from some of the new OEMs and what we're working on in some of the architectures, I think the goal here is to get that charging time of a vehicle down into that same 5-minute range. So if we can get that into the 5-minute range, then you've really eliminated that inconvenience factor of what you had for the traditional electric vehicles, because now you can charge that vehicle at the same time that it would take you to fill up your vehicle. Plus, it gives you more convenience in that you can charge it at a charging network, you can charge it at your home, you can charge it at your hotel when you get there, whereas you had to go to a traditional gas station. Now you'll have multiple points to be able to charge your vehicle. But to me, I think that's really the key to unlocking the electric vehicle market, is really figuring out how to get that charging rate down.
How does the electrical architecture change when you get there then?
Well, the big thing that we see is the different voltage architectures that we see. Right now, with where we see some of these architectures going in a vehicle, there's a lot of talk on an 800-volt architecture, and then there's even some talk on going to a 1,000-volt architecture. So as you see those bigger architectures come in, that's what you really need in order to push this charging time down. Think of it as trying to fill up a bucket of water. It's how much water can you dump into that bucket as quickly as you can. If you put a small hose on there, you're not going to get much. You put a fire hose on there, you're going to fill it up more so. So that's what we're really talking about when you get to that faster charging rate. It's how much energy can you push into a vehicle as quickly as you can. So you have to have these bigger architectures to do that. So I think that's really where the key on this 800-volt versus 1,000-volt architecture, to me, those are going to be the key to unlocking this 5-minute charge time.
How do you think it can be done safely? Because the first thing that goes to mind is heat, and then the amount of electricity. We all have USB cables floating around our houses, and they open up. Okay, no problem. But 800 volts or 1,000 volts open up. How do we do that safely?
Yeah, I think that's the real balancing of the equation here. It's from an engineering standpoint, you have to be able to push that much energy in order to get that charging rate down. But when you push that much energy in, of course, it's going to turn into heat. So then you're really looking at these architectures. You're looking at the safety of the vehicle. You're looking at, do we need to do something in terms of some type of cooling system? Do we force air into it? Do we do some type of liquid cooling? What do you do in order to keep the heat down, to really dissipate that away from the vehicle? and away from the consumer. I think the technology is there that'll allow us to get to this 5-6 minute charging rate, but you have to balance that with how much of that can you put into a vehicle while still keeping your vehicle and your consumer safe. So I think that's where we'll see the real innovation come in here with engineering over the next couple of years, is how do you balance that equation? You'll see different types of bus bars, different sizes of those. I think we'll see, like I said, some type of a cooling factor coming in with either forced air or some type of liquid. But in order to really get this charging rate down, there's probably going to have to be some add-ons that we have to do to the vehicle and to the charging network to allow that to happen.
If you look at the market, it's called the shift towards electrification. There's a common denominator. The market's changing rapidly. How is ENNOVI, how are you able to stay ahead of that and react to that market quickly, instead of traditionally where it's like, okay, we're on a 7-year cycle, well, that's not going to work anymore. How are you able to do it quickly?
Yeah, I think being global certainly offers us the advantage of having manufacturing and engineering set up in different regions, so we can react quickly as we see the different regional perspectives coming in. So I think we have that aspect going for us. I think the other thing that we need to really be looking at is, what are our contingency plans for how do we see the market continually develop? You hit the nail on the head when you say, hey, if we looked at engineering and OEMs 5-10 years ago, you were typically on a 3 to 4 year development cycle. You had a lot of time to prototype. You had a lot of time to interact with the OEMs. You had a lot of time to do trial and error before you ultimately got to what we would say is that ideal solution. Here we see now the OEMs moving so quickly that our design cycles are cut in half. We see a lot of design cycles now that are less than 12 months. So there's a particular amount of risk that you have to take to do that, but at the same time, you need to make sure that your designs are still validated and well enough. You don't want to put it into a vehicle without having some of those I's dotted and T's crossed for sure. So the big thing that ENNOVI has really tried to do is we do a lot of upfront simulations. So we're using a lot of software to our advantage, to where in the older days, 10 years ago, we would do a lot of prototyping, and then you would go see how does that part work in this environment. Now we're starting to use some of this compute power and some of these simulation package to say, here's how the vehicle is going to react. Here's the different situations the vehicle is going to be put in. Here's what our design is going to look like. And you put those parameters together and you say, okay, let's simulate now what the effect is going to be of those two factors on one another. So that's really how we've been able to bring our product life cycles down, or our time to bring a new product into market, is by really utilizing those simulations to help us on developing those technologies.
Did you build your simulation platform in-house, or using a third-party vendor to do that?
It's a combination of both. I think certainly we have to rely on what we see from some of the suppliers with some of the bigger packages, but then we get into some pretty unique and specific aspects of our designs. So we work with the suppliers to tweak the packages a little bit to our preferential need for what we need to do, but it's certainly a combination there of how we build those packages.
So today you're down from the historical 3 to 4 year to a 12-month design cycle. Over time, the simulation's getting better. It's amazing. Every week, seemingly there's a new breakthrough. Could we eventually get that down to a 6-month design cycle over time, do you think?
I don't think we're going to have a choice, to be honest with you. I think with what we see, as quickly as these architectures and these OEMs are moving, I think that's going to be the desire. I think, again, you really have to balance that out, though. How much testing do you want to do simulation versus how much testing do you want to do with real-life parts? I think we're still going to see a lot of requirements from the OEMs of where they're going to have to do some advanced builds, some durability builds, some prototype builds. So, 6 months might be pushing the envelope a little bit, but like I said, I think we all have to plan for that, because at some point there's going to be some customers that want to move that fast.
So how do you find that balance between simulation and real life? The real life is expensive. It takes time, but if your OEM customers demand it, how do you find that balance?
No, that's a great question. It's really all about risk management. So you have to look at how do you manage your risk. Certainly, you can rely so much on the simulation package, but I'm a true believer in that you still have to have some type of physical testing to go along with a part before you would ever sign off it and say it's allowed to be in a vehicle. So there's a lot of requirements that we see from both ourselves as an automotive supplier, as well as a lot of the OEMs. What do we have to do with a new part or a new design or some type of a new perspective architecture? What do we have to do with that before we put it into a vehicle? So you've always got to have consumer in mind as number one. Certainly, we always want to move fast, and we always want to bring the new technologies in as quickly as we can. but you really got to make sure that you're protecting the consumer and the overall vehicle before you put it on a cadence that doesn't allow you to maintain that level of protection.
You have to have the risk management because your customers, the OEMs, they're brands, and consumers react to brands. Suppliers, most consumers don't know who the suppliers are, but they know who the brands are, and so you have to build that trust between yourself and your OEM. And staying on the risk management topic, we can't talk about risk management today without rising global tensions and tariffs. How are you managing those risks that are, we go to bed, we think it's one thing, we wake up the next day, it's another? I'll use the term, they're seesawing on a pretty rapid basis.
Yep. No, that's a good question. I think in terms of what we've seen for tariffs, it hasn't impacted us, ENNOVI, yet as much as what we've seen some of the other suppliers as well as some of the other OEMs. I think everybody's kind of in that cautious wait and see what kind of happens with tariffs. But at the same time, we have to build contingency plans in the background. So certainly with us being a global supplier, we're looking at that in the background to say, if we had to move from one area to another, do we have the capabilities to do that? Same thing with our OEMs. If our OEMs are moving from one region to another, or if they're asking us to move supply from one region to another, how do we react to that? So it's all about contingency plans at this point, but we're very active in putting together those contingency plans. I think right now it's a wait and see for how much of those contingency plans do we actually need to enact and actually start making some movements with those.
Are there changes from different EV architectures? Because if you're putting it to the EU, you're putting it to APAC, you're putting it to North America. Are there any risks in that from different changes because perhaps it's using different parts?
Certainly, yeah. With what we see for the different architectures, you'll see different areas of design come in the different regions. Probably the biggest impact that we see from the different regions is how our battery suppliers are setting up their individual cells. We work with how we do the battery management system with our CCS. We really look at what's the different designs that they're bringing into the battery supplies. So we see prismatic designs, we see cylindrical designs, we see even the new pouch cell designs coming in. The good thing is we as ENNOVI, we've offered up solutions and we can design solutions for all of these different battery designs, but that's an area where you really need to work with your OEMs and your battery manufacturers up front to decide with them what type of cells are you utilizing, what's your layout going to be, how are you going to do this. And once they kind of come to us and tell us that, then certainly we can build a solution that goes along with that. And then you see customizations going on with some of the different charging sides of the vehicles as well. With one area where we see a big push for PHEVs, the charging's a little bit different with those. And then you look at China and they're really all about full EVs. So you see a little bit different architectures with those. So I think the good news for what we have in ENNOVI is we offer a catalog to where we can adjust based off how we see the different regions and the different customers coming in for their different design aspects. But yeah, we do see some differences between regions and certainly between the OEMs.
Is there a lot of customizations that goes into these EV architectures on a different OEM basis or even a different regional basis?
Certainly. And it really comes down to size. It comes down to size. It comes down to layout. It comes down to what you're doing with that overall design of the pack. I think the philosophy is the same there with how do you link up all the different cells going inside the batteries. But you'll see a lot of different design configurations and a lot of different build patterns with how they do those. So with each of those, we really do have to work with our OEMs to customize those. We try and push to get as much commonality as we can, so that way we can keep the cost down, but we still see a lot of customization within the different OEMs.
Is there ever that OEM says they want to over customize it, and then when you come back and you say, oh, hey, this is what the price is going to be, they come back to, let's say, a more common architecture that your other customers are using?
Oh, I think they try to, and I think we try to help them develop that. I mean, cost is king. Everybody knows that cost is king. So it's all about how do you provide the most economical solution. So I think everything starts out as a great idea. That's what we do in engineering, is everybody comes up with what they think is the best idea and the great idea. But to me, I think where we can really help is then to get into that collaboration discussion. OEMs and the battery suppliers will start with what they want with their design. We can then collaborate and say, hey, we've seen where we can do this differently, or we can offer up this type of solution, or we can take some cost out here. So I think it's that back and forth that we have between the engineering teams where I think we can really start to benefit the customers. So I would say we probably start out a little bit individualized with what we see coming in with some of the battery and the OEM solutions. But our job is to really try to push some commonality there so we can really start to bring the cost of those overall designs down and help make the vehicle affordable in the process.
During those collaboration sessions or when you're in those meetings, what are some of the biggest engineering challenges that you've seen emerge, and how has ENNOVI overcome those engineering challenges?
Oh, I think the biggest engineering challenge is always trying to get engineers to align and agree on things. But that's not something that's specific to electric vehicles or what we're doing with charging and battery supply. But I mean, the biggest thing I think is you just see the technology moving so fast. So what might have been a great solution 6 months ago or 12 months ago, we'll see a new supplier come in with a different type of cell design or a new OEM come in with a different type of layout. And it's really about how can you adapt to those as quickly as you can. So to me, the biggest challenge is really getting that collaboration and working together as a team. We see this all the time where, one group will think, hey, this is a great idea. Another group will think this is a great idea. And then we'll have another group think this is the best idea. It's how do you really get that team overall working together to come up with the best concept possible?
Staying on the engineering theme, how are the engineers preparing for the next generation EV platforms? Because I'm sure you're getting asked from your customers, oh, we're working on this next platform. How are you preparing for that?
Oh, I think the biggest challenge right now is trying to predict the market. So it's what do you want to be working on now that's really going to get you the most supply and the most customers 12 to 18 months down the road. To me, that's the biggest challenge that we see. Again, with this market moving so quickly, what we design is what we think is an optimal solution right now. There's going to be enough competition. There's going to be enough design changes in there that what was the ideal solution today, 12 months down the road, it could be something completely different. So it's really trying to figure out how can you capitalize on your overall design and match that up to the market as best as you can. Ideal situation is we want to sell our product for the next 3 to 4 years and continually, putting that into production. We don't like a 12-month supply cycle. We want 3 or 4 years worth of production once we're in production. So really, to me, the biggest challenge right now is predicting the market. So how are we designing the right catalog that is going to satisfy the market needs 5 years down the road?
Predicting the market's extremely tough, but Ron, in your opinion, what is the future of electrification?
Oh, that's a good question. Future of electrification, in my opinion, I still think you're going to see a combination of hybrids and traditional full electric vehicles. You're always going to have that anxiety that's always going to persist amongst some of the public. I think you're going to see a stronger transition over to the electric vehicles. I think we have to eliminate these inconvenience factors of range, the inconvenience factor of what we're doing for the charging time. I think once we get those behind us, I think you'll really start to see electric vehicle populations start to pick up. We're already seeing that in Asia Pacific. We're already seeing that market start to develop there. I think there's always going to be a need for ICE vehicles, and I think there's always going to be that transition with the hybrids of how do you really bridge the gap between somebody that's afraid to go to an electric vehicle and wants to stick with an ICE. So you have to give them that convenience of being able to drive somewhere on a vehicle charge, but not have that anxiety of what happens when I run out of charge.
If you look at APAC, a lot of individuals in North America and Europe have passports. Germany actually is the highest rate of passports per capita for any country. When individuals travel, they rent cars. Do you feel that as they go to APAC or to a region with a high exposure to electric vehicles, they get in their rents, wow, this was great. This was cool. I went through here, and here, and I had no problem. Do you think that could possibly help accelerate the adoption of electrification just from that experience that they might have had?
I think it's eye-opening. I actually spent the last 2 weeks in China. So coming from where I am here in North America to spending 2 weeks in China, just seeing how they've embraced that transition over to the electric vehicles. China's kind of unique in that you can tell by their license plates what's an electric vehicle versus what's a traditional ICE vehicle. And just to see the amount of electric vehicle license plates that are driving on the road, it had me shaking my head saying, hey, I think there's really a possibility that we can really see this transition start to happen. Is it ever going to be 100% transition? No way. I think there's always going to be that need for either a PHEV or some type of ICE in the background. But I think if you get more people seeing that transition is actually possible, you see some people getting that stereotypical thing out of your mind of the inconvenience factor of having to charge the vehicle and it takes so long to charge the vehicle. I think once you get and eliminate some of those stereotypes, I think you'll see the market start to move there. So I think your question is the right question. Can we influence the market by showing that it's capable, by putting out literature to show that it's capable? I think that's certainly going to help. but I think you're still going to have that strong opinion from some base to where I don't think you can fully transition to a full electric vehicle at 100% of the market at any time soon.
I agree with the statement around the 100% of the market, but I do believe that we will see greater adoption once individuals experience it or live with it for a certain period of time because they get comfortable with it. And especially when they don't have to own the product. And from a rental car perspective, that works really well. What we do know is that ENNOVI is enabling the future of electrification. Ron, as we look to wrap up this insightful conversation, what would you like our listeners to take away with them today?
Oh, I think it's all about embracing electrification. So that's really my message for today is, embrace electrification. I think there's a tremendous amount of effort currently going on in the automotive industry and trying to produce a market or produce a vehicle that satisfies all the different types of customers. So when you look at whether it's a full electric vehicle, if it's a plug-in hybrid, or it's a traditional hybrid, there's lots of different options out there. Electrification is here to stay. So I think to me, it's all about embracing electrification. The more we embrace electrification, I think the more that we'll continue to be able to design more products that satisfy the public. So the quicker that we can get people to embrace electrification and start bringing in more ideas of what do we want to see different in electric vehicles? What do we want to see different in the grid? What do we want to see differently to make it more convenient? Then I think we'll see this transition start to happen a lot quicker as well.
I'll follow Ron's lead and definitely agree. Embrace electrification. Me being me, drive electric. It's fun and it's convenient. Today is tomorrow. Tomorrow is today. The future is ENNOVI. Ron, thank you so much for coming on SAE Tomorrow Today.
Yeah, thanks for having me, Grayson.
Thank you for listening to SAE Tomorrow Today. Be sure to join us next week as we explore how Electrata is working to accelerate the adoption of fleet electrification.
SAE International makes no representations as to the accuracy of the information presented in this podcast. The information and opinions are for general information only. SAE International does not endorse, approve, recommend, or certify any information, product, process, service, or organization presented or mentioned in this podcast.